Hello friends, I welcome you all to this session on numerical methods using C++ programming. So today's topic is linear regression. So now, what is linear regression basically? So let's say I am having some data that is x, and with x, y changes. So I am having some data points. My task is to fit a line in this particular such that the distance of the value of y on this line to the actual data point at each and every point, if I find out the square, then that particular error should be least. So this is basically a method of finding out that particular least square error and then fitting that line. So, but if you are not able to get it, you can simply think it like this. You have to fit a line which best represents this data. That's it. So what is equation of a line? Y is equal to mx plus c. Now, what is this m? M is the slope of this line. C is the y-intercept. That means where the line is intersecting the y-axis. Now, as we are having discrete data points, so what we'll do is, we will sum this up for all the number of data points. So that will give you sigma y m sigma x plus. So if you sum c n times, where n is the number of data points, so that becomes n times c. If you multiply this equation by x and then take the sum, so this will become sigma xy is equal to m sigma x square plus and then cx, so it will be c sigma x. Now you do what? Let me bring these equations down. Now you do what? You multiply this equation by sigma x and this equation by n and then subtract these two. So if you subtract, you will be getting sigma y sigma x minus n sigma xy is equal to m sigma x whole square, and then this is minus n sigma x square. So n sigma x square. Oops, where it has gone? Slightly to the right. Okay, n sigma x square. So from here you can find out what is m. So I will do what? I will take negative sign from numerator and denominator. So it will become n sigma xy minus sigma x sigma y divided by n sigma x square minus sigma x whole square. Once you know m, to know the y-intercept, so now you have your slope. So to know the y-intercept, what you can do is, you can use this equation. That is, equation means without this term. So this will be n will be sigma y minus m you have already evaluated, let's say using this, and then sigma x divided by number of data points. So this is my data, let's say 1 2 3 4 5 1 2 3 4 5 6 7. So 7 in totality data points are there, and I want to fit that line. Now what I will do is, I've already taken this data here. So let us start the program. I will keep these things at the appropriate places. Don't worry. So hash include iStream using namespace standard, then int main, and then return 0. Now you should have your arrays of x and y. So these are my arrays. So let's say it is double, and as they are of same shape, so from any shape I will evaluate the number of data points. So int n is equal to the size of x divided by the size of zeroth element of x. So let us check what the size comes. So if I run it, so 7 data points are there, and you know it. It is 1, 2, 3, 4, 5, 6, 7. So 7 data points are there. Once this is done, now if you look here, you require sigma x, sigma y. So let us create variables. Double sigma x, let's say sigma x, sigma y. Then you will also be requiring sigma xy, and apart from this, you will be requiring sigma x square. So let's say these are my variables. Once more, I'll tell you sigma x, sigma y, sigma xy, sigma x square. So now I'll write a loop for int I0, I less than n, I plus plus. What I have to do? I have to shift this. So what I have to do is I have to evaluate the sum of xy. So first, let us initialize this with 0. Right now, we can use uniform initialization. Once this is done, then you can say sigma x is nothing but sigma x plus xi. So what we are doing here is we are summing up all the elements and storing them into this. Similarly, what you can do is you can evaluate sigma y. What will be sigma y? Sigma y will be sum of all the elements of this array y. So this is sigma y. What about sigma xy? This sigma xy, it is nothing but the sum of the elements of the product of x and respective y. Okay, and then finally comes sigma x square. So sigma x square will be equal to the ith value, that is 1.5 into 1.5 plus 2.3 into 2.3 plus 2.9 into 2.9. So that means into xi. That's it. Once this is known to you, now you will be evaluating the slope m. So slope will come out. Let us declare here, as well as let us declare the y-intercept c. Then the slope will be equal to, if you remember, it is n sigma xy. So n times sigma xy, then minus sigma x, sigma y. So minus sigma x, where I'm writing, minus sigma x times sigma y, and this whole will be divided by n sigma x square. So it is n sigma x square minus sigma x whole square. So it is sigma x whole square. That means sigma x times sigma x. Sigma x times sigma x. That's it. M is over. Now comes C, y-intercept. So y-intercept will be equal to sigma y minus m times sigma x, m times sigma x, because now I am having m, so I can use it here. This divided by number of data points. That's it. So simple. Linear regression is very simple, friends. It is over. Now you just have to print. So cout m is equal to m and c is equal to c and let's say end l. That's it. Okay, done. So if you run it now, so you will be getting for the data M as 3 point this and C as this. So what we'll do is we will go to Excel and then we will see that how this particular thing looks. So what I'm having is I'll copy this from here and go to Excel. So what I'll do is I'll transpose this X as well as Y. So I'll transpose this, copy, and then transpose. Okay, once this has been transposed, so there is no use of this. Okay, now I will first plot these. Okay, I'll plot, insert as data points. So these are the data points. Now my task is to fit a trend line. So M, which is equal to 3.87982. So 3.87982 is my M, and the y-intercept which I have evaluated is minus 2.55078, minus 2.55078. Now I have to fit a line. So y is equal to M, fix this cell into X plus C, fix this cell also. So now you select data, add, X axis will be this only, and the Y axis will be this one. Okay. Okay. Where it has gone? Where it has gone? So let us select data once more, add, X axis is this one, and the Y axis is this one. Okay, and then okay. Why I am not able to see anything? Have I done something wrong? Let us copy and paste as numbers. Okay, now okay, previously it was coming as image, I think. Yeah, that's why X and Y are looking hazy. Doesn't matter. Now this is for line. What I'll do is I'll change it to from scatter plot to line. Okay, now friends, this is your trend line. Basically, this is your linear regression line. Now, with the help of C program, you know that how to write a linear regression program. And this is a very simple thing. What you have to have X and Y arrays, size of data set, then sigma x y, sigma x y, sigma x square, then add them. That's it. Use the formula and get the answer. It is so simple. So in this lecture, till this point only. Thank you very much for watching it.